Guys, make sure I get this copied down correctly.
Please, is that the one we spent so much time on? Oh. And we have the zeros. Okay. Now, just to show you right quickly, this can be a benefit here. And of course, we're looking for any benefit we can in searching for these. Guys, try the blue mark and see if it's going to work for me. Suppose I set this up by synthetic. I'm searching for the answers, and by synthetic, and I had this, much better, set up as we did earlier, and we start testing. We've already gone through this. I just want to point something out. And let's say a student told me, I want to get an input from you, Professor, try one. We may have tried one earlier when I actually did this. I will try it. That's a possibility. 0, 2, 2, do not let me make a mistake, 13, 13, is that 43? So at this point, I would say, no, it's not looking good, but I'm gonna finish it up. 1 times 43 is 43. Guys, what strange number would I end up with if I actually complete it? It's not gonna be a 0. It's not gonna work. What is negative 18 plus 43, what is it?
25.
25. I end up with a 25. Watch carefully. Didn't work. Then I have a student who says, Professor, in testing, and I think a possibility was -1. They tested -1. But we didn't know what works. 2, 11, 30, negative 18. And if Ignacio, he's trying -1, he said, Professor, I think that's going to work. I'm testing. Let's see what. There you go. 0, 2, -2, 9, I guess. -9, 21, is it? -21, guys, what would I end up with here? A -39, I did it quickly. Did I? Did it work? Listen, Ramsey, why are you wasting time? You know, we've already done this problem. We found the 3 zeros, didn't we? We finished this problem up. But something to point out. Suppose a student did that. I would have done that as a student. Test 1, it didn't work. Now I get frustrated. Test -1, professor, it didn't work. But it's telling me something. It's telling me something that might help me find one of the zeros. First, we point out, no, it didn't work, but this all means when x is 1, y is 25. That means if you should do this by direct substitution, go up here and replace all these x's by 1, if I get this number I test, by 1, guarantee you if I have no mistake, I hope I don't have a mistake, you're going to get 25. If you did it directly. So that's why I like synthetic. This one down here, no, it didn't work, but it tells me when x is -1, my y is -39. If I have no mistake. So that would be a quicker way to find it rather than substituting all these x's by -1, which will give you a -39 also, more time spent. Is that true, guys? Now, can anyone tell me what's the benefit? Be clever for me. What on earth is the benefit? And I'll tell you one more additional detail. If we were to graph this, by the way, did I graph this one? I didn't, did I? But if we should graph it, you're also guaranteed this point out 1 up 25 is on that graph. And this point here, -1 down 39, is on that graph. Now, can someone make a statement for me? Help me out. And you're going to be shocked that you've got to be aware of every little thing happening here. Shane.
There must be at least one real 0 between these two.
Look at this. She says, Professor, if you plot this one, out 1, up 25, let's set up here, guys. And if you plot this one, -1 down, what, 39? It's way down here. -1, -39. Is that true? And you know they got to be connected. supposed to be some type of a curve, is that true? And you may say, Professor, if it's connected, please tell me, as I connect, would I have to at least one time, cross the x-axis to get from this point to this point? And when I cross the x-axis, you found a 0. The x-intercepts are the zeros. So this thing might do this for me in my curve. You say, oh, Professor, to get from here to here connected, and God connect them, it's continuous, you're going to cross the x-axis somewhere. So what are you going to do now to try to find exactly where did you cross and find one of the zeros? You're going to go back and start testing numbers that fall where? Between -1 and 1. Is -1/2 one of the possibilities we had before the break? In fact, did -1/2 work? Did -1/2, would it work out as a 0 or a positive 1/2? Was it positive 1/2? Beautiful, here we go. Does it make this even look better? No problem. You say, Professor, it looks like it may do this. We can connect them. So it's connected. Now, does it cross the x-axis? It does. I made it now look more like what I'm looking for. Is that a 1/2 maybe in there somewhere where it crosses the x-axis? You found it. So that tells me now, if I had known this, when these signs change, one's above, one's below, and to connect them, they're got to be connected. You're going to cross the x-axis. Then what are you going to do? You're going to go to your set of possibilities and find one of those numbers that falls between. And I think, guys, students are telling me, Professor, 1/2 falls between. Does it fall between these two? And did we test 1/2 earlier, guys? Did it work? That would save me. I know what, as a student, I got frustrated. When I saw early on it was not going to give me a 0, I stopped. I may have stopped here. And then start testing a different number. No, if you carry this thing all the way out, it might benefit you. You see a sign change. Billy, you have the handout. Would you try to find intermediate value theorem? Just read the statement to us, and then we'll move on.
Says let f denote a polynomial function if a is less than b, and if f of a and f of b are opposite signs, there is at least one real zero of f between a and b.
Right, here's what the intermediate value property says, or theorem. Translated, that's on your handout. That's what the theorem says. If you see a sign change, you expect a 0 to fall in between. Okay? That's the intermediate value theorem. Now, where am I? Oh, I'm over here. Who knows, when I start testing this one, I may see a sign change over here. Now, some of my students, I think, during the break, I think they looked at this. Guys, I'm expecting 4 zeros. Let's see how much time I got here. I'm expecting 4 zeros. I've got all the possibilities, and I think a student, Ignacio, you gave me 1/3, and it worked. So that says I've got 3 more to find. We may have lucked out a little bit here. Descartes says 1 should be positive. Ignacio found it for us. It says 1/3. Positive 1/3. Now, guys, if I stop at this point right now and not do additional testing, which could happen, sometimes will happen, and I write out what those remaining numbers mean, rather than additional testing, because additional testing takes so long. I start out with a, 4? I found one of the answers. Now I'm dropped down to 3 remaining. Do these numbers down here represent a cubic? So you can say, wait, Professor, don't do additional testing. Rewrite this as this. It sometimes lucks out and works. True, guys? Guess what? I can group this one. I can do grouping on this one. Group here. Group here. In that first grouping, guys, take out a common factor of 3x squared, no problem. We've got x plus 2. My last grouping, take out a common factor of 27. 27 will go into both those numbers. X plus 2. And you know how grouping works. Now take out what altogether? X plus 2 is in both of them. Look at this. When you take it out, though, you're going to be left with 3x squared plus 27. You guys in the back there. That's what, I think that's what you guys were telling me. They were telling me as they walked out from the break. You guys agree? No additional testing. The only number I tested was this one that Ignacio gave me. I could test others for sure if I didn't. I'm using this little process. Now, if I set this equal to 0, guys, and split this up, immediately, I get a -2. So that means I can add to what he gave me. He gave me a 1/3. I can quickly say, another one of the zeros of the 4 is a -2. No problem. Take this factor. You know how to do this, zero product property. Set this equal to 0. Move that 27 over. Divide by 3. Do I get that? And that's a small quadratic. Has 2 answers to it. And to find it, take the square roots plus minus. Square root of a -9. That is to ensure I get 2 answers for this quadratic. And guys, square root -9 is best expressed as?
3i.
There you go. And now you have all 4 zeros. Is that true? Pretty good? Now, does it always happen like that? I wish it did. Not always. But when you can use something like, take these numbers and rewrite it right quickly like this, go for it. That'll save you a lot of time. I have the 4 zeros. Now, help me put this in factored form. I'd like to know what, I'll put it in a different color. What does P of X look like in factored form? Guys, first start out with a nice factor that would lead me to 1/3. 3x minus 1. Beautiful. Give me a nice factor that would lead me to a -2. X plus 2. Now, 3i. 3x minus 3i. And -3i? X plus 3i. That's your factor form. If I say leave no I love that right there. If I say leave no I, that means you do what? Multiply these 2 together. Let me try to find it here. And try to eliminate the I. Shane, that might lead me back to something you were talking about before the break. What do you think those 2 multiplied together will give me? If I multiply by A plus B times A minus B, just FOIL, they call it FOIL, you guys call it FOIL. But I end up with x squared minus 9i squared. Multiply those out. Is that true? Use FOIL. Or, better yet, x squared subtract 9 times what's I squared equivalent to? -1. Where I end up with x squared plus 9. All together. Yes, no? So that means I would add with this P of X, and use a different color. If they say leave no I, the other factored version would look like this. 3x minus 1 is in fine shape. X plus 2 is good. But on the end, just in case, that would now be written as what? X squared plus 9. Okay? You guys agree? Mathematics. Mathematics. I think some of my students are seated and they just are amazed. I was. In grad school, when my professors were doing this and doing that and bringing this in and that in, and some of the professors were not, they're crazy. But anyway, yeah, let me see how much time I have here. Let me share with you a little short story. One of the professors, and they do get sort of crazy. Not all of them, but some do. You go on the campus and they've been there for years and years and years, and they know their mathematics, they got the PhD from MIT, and they know all the business. So we had this one, and he was always late. But they had a rule back then, you had to stay at least 10 minutes.